Okay? In the equations for progressive waves, a progressive wave equation is represented with the formula y equals a sine bracket omega t minus phase angle. This a can be represented with small a. Yeah, either small or capital, they are all okay. And it is amplitude measured in meters. Omega equals angular velocity or angular speed, as I called omega. Then t equals time. Phase angle, we have a phase angle, that is my mu equals phase angle measured in radian. Okay, but phase angle can be calculated using kx, where k is phase constant, x is distance. Okay, we now replace kx for phase angle in equation 1. We now have y equals a sine bracket omega t minus kx. But k is calculated using the formula, that is phase constant is calculated using the formula k equals 2 pi over lambda. We now substitute this for k in equation 2. We now have, we have lambda is called a wavelength. It is measured in meters. We know that pi equals 22 over 7. Now replacing this for k in equation 2. We now have y equals a sine bracket omega t minus 2 pi x over lambda. Then from the formula omega equals 2 pi f, one of the formulas for calculating omega, we use it to replace omega in this equation 2. Then we now have y equals a sine bracket 2 pi ft minus 2 pi x over lambda. Okay, where f is frequency. Okay, we now factorize. We have 2 pi, we have 2 pi. Because both of them are in the numerator, we can factorize them. 2 pi, pick one. We now have y equals a sine 2 pi bracket ft minus x over lambda. Call it equation 4. This one is equation 3. Then from the formula for one of the formula for calculating frequency, we have f equals, that is velocity of the wave, making f the subject to have v over lambda. Substituting back to this equation, we have y equals a sine 2 pi bracket vt over lambda minus x over lambda. Remember that v over lambda is in place of this frequency. Good. Then we now have equation 5. Then, okay, sorry, not equation 5 yet. Then we factorize, having done that, we factorize this lambda. The lambda, 2 of them are the denominator. We now factorize the picking one. When we pick one, the equation becomes y equals a sine 2 pi over lambda. Coming now as a denominator, it will be this over lambda. Then bracket vt minus x. Now equation 5. Where v is velocity. Then from one of another formula for calculating frequency, we have f equals 1 over capital T, where the capital T is period, which is measured in seconds. We substitute this now for f in equation 4. So from equation 4, this is what we have. Substituting this for f, we now have T over capital T, small t over capital T. Remember that 1 over capital T multiplying T will give us this, now minus x over lambda. That is equation 6. Now, we substitute v over f for lambda in equation 4. Then in equation 4, substituting v over f for lambda here, we now have y equals a sine 2 pi bracket ft minus x over v over f for lambda. Then solving the mass, this divided by this. But inverting this now, when you change it to multiplication, it will now have f x times f over v. This will now give us y equals a sine 2 pi bracket ft minus x f over v. We can now factorize frequency. We now have y equals 2 taking one f. Y equals a sine 2 pi f bracket the remaining t minus x over v. That is equation 7. But from our formula here, we notice that 2 pi f is for omega. We now use this to replace this back here. We now have y equals a sine omega, replacing the whole of this bracket t minus x over v. That is equation 8. Then from another formula for calculating omega, that is theta over t. This theta is called the angular distance. This remains time. We now substitute this in for omega in equation 3. See equation 3 here. We now go over to this place. From equation 3, substituting, we have y equals a sine bracket theta over t times the already t there, which will now give us theta t over t minus 2 pi x over lambda. We cancel t, cancel t. We now left with what? Y equals a sine bracket theta minus 2 pi x over lambda. That is equation 9. So we have almost 9 equations for calculating progressive waves. We are now in calculations. Let's now hit the calculations in the next phase.